Hello everybody, let's get started. I'm Jesse McFadden. I'm going to talk to you today about mobile optimization and how to make your code run awesomely fast. A nice little quote here. This is extremely relevant to optimization, and I'm going to discuss it somewhat in depth. So one thing to know is that a lot of people think that they're striving for optimization when actually, if you don't have a good understanding of how your code executes, you can actually make things a lot worse. So my name is Jesse. I'm a PhoneGap contributor, a developer, yada, yada, yada. I've been with Nitobi for the last 3 years. I've built a lot of large-scale JavaScript applications, a lot of PhoneGap applications. Before I came to Nitobi, I worked primarily in ActionScript. So I was doing large-scale Flash and Flex and Air applications for about 5 years before that. So I've sort of been around the dynamic language for a while. So I've gained a lot of insights over the years about how to write effective code for, especially nowadays, running on mobile devices. So first of all, what is optimization? We're going to start at the very top. It's removing any of the corrupt or the unneeded code. You want to keep your application as streamlined as possible. So identifying bottlenecks in your code and optimizing them so that they run effectively. Some things that you can do to optimize are stripping unused code or combining and refactoring code that's repeated. Generally, you want to follow best practices when you write the code, and this will make your life easier when it's time to optimize. And you can also use optimization to tweak your code to get extra performance out of device hardware. So most optimizations fall in either a time or a space category. So you can optimize for the amount of space that you take up at a time, and this usually includes throwing away things that you don't need access to quickly. It just means that you're going to have to load them when you need them. And the other optimization, and the more common one, is to optimize for time. So this implies that you sacrifice some space in memory to have things ready for you to display. And that's primarily where we work when we're in mobile. Ultimately, it's a balance between the two, and you usually sacrifice one for the other. So generally, you want to discard infrequently used data, and you want to make sure that frequently used data is available quickly. So the important decision here is when and where you should optimize for speed. So what you should be doing is you should be looking for bottlenecks in your code, and this is the area where you should focus your efforts. It's been said that when an application is running, 90% of the time is spent in 10% of the code. So if you can focus on that 10% and identify that and optimize that, you're in good shape. So there's multiple ways that you can look at optimization. You can look at it as a task that you do towards the end of a dev cycle. You could do it with each iteration, each time that you decide to refactor your code, or you could continuously try to maintain something that's optimal. Continually maintaining is not necessarily the best way to go because it's extremely difficult to do, and it's hard to maintain nice-looking, readable code if you're constantly trying to make things optimum. So one extremely important thing to do when you're considering optimization is you need to have some sort of frame of measurement to actually make sure that you are improving the execution time of your code. So in JavaScript, this is pretty easy to do. I've got a little snippet of code here, which we're basically just getting the start time, and then we're doing some work. Then we're getting the end time, and we're outputting the result. I just noticed that my screen is not.
There you go. Wait, can you go back to your presentation for a second?
Okay.
There you go. Just carry on.
All these slides will be posted after. I haven't really done a lot of information on my slides. It's mostly been verbal, so you should be okay. It actually looks like it's still not updating, like it's stuck on that.
You're using Keynote, right?
Yep.
There's a setting in Keynote that we might have to set, or you can not go full screen mode if you want. But there's I believe that's what it comes down to. There's some setting in Keynote. Hold on 1 second. Keynote. Properties.
Okay, we're live. Sorry about that. Okay, so we covered the categories, when we should optimize, what to optimize, find the 10%, and we're on to benchmarking. So here you can see a quick example, and all we're really doing is we're keeping track of how much time it's going to take to do the work in the middle. So, and I'll show you a quick demo to demonstrate that. Okay, I'm in a PhoneGap application here. This is iOS in Xcode. So I'm setting up I'm creating an array of 1 million integers that I'm pushing into the array. Then I'm going to keep track of what time I started this test. I'm going to do a nested loop, and we're going to compare accessing data array and using length, which is a known not best practice. We're going to compare that with the actual best practice of storing a variable for the length of the array so that we don't continually check every time we go through this loop. And all output is just spit out to the console. So running this and switching to debug mode, we can see there's not actually that much difference between these two. So jumping back to our code, we can play with a few things here. So since we have this basic loop set up, we can actually compare different scenarios. So if we make less numbers in our overall array, and then we decide to run our test more times, then we can see, okay, there's a little bit more difference when we run our test this way. So this is telling us that running the same code repeatedly, so we've got an outer loop, so we're running this test essentially 400 times. In this case, it actually does demonstrate that using this local variable for the array.length is improving our execution time. So now if we move on to actually do some work inside of our loop here, we can compare the difference. And this is actually a more realistic indication because you're usually going to be doing something inside your loop. So you can see here that it took 506 milliseconds checking array.length every time through the loop, and it took 462 milliseconds by storing the local variable for the length of the array. So this gives us a good starting point. You can imagine that you've got some of your own code in here, so you can use something like this to actually test the execution time and speed and make sure that you're actually making a difference in your code. So the key things to learn from this is run your loops a lot, run your tests a lot. Usually it takes an accumulation of time before you can actually see a consistent difference between the two. One thing to be aware of is sometimes if you don't have your tests set up completely right, there may be a difference between running your tests in different orders. So that's something that you may want to try and make sure that you're not seeing different results when you switch the order of your tests. So the main thing is if it isn't broken, don't fix it. And also be realistic, because we can spend a lot of time trying to optimize that loop, but it's really best if we look at it with a realistic situation and the way that that function is going to be called, and that'll give us a better understanding of whether we actually need to spend the time to optimize. So here's an example that I actually have seen. It's a little bit of extra pseudocode in here, but the point is that this developer has decided that they can save some space by naming their variables A, B, C, D, and E. So looking at this function, it's pretty much impossible to tell what it's doing. You can tell that it's expecting A to be a function, and then it's passing the rest of the arguments on, but who knows why, and this is not the way that you should be writing your code. So there's tools that will do that for you, and so it's important that you decide to let the tool do that. Minification is the practice of making your JavaScript as small as possible. So what minification does for you is it makes your code load much faster because there's less to process going over the wire. So especially relevant if you're doing network JavaScript, so say loading from a web server, but also still relevant within a PhoneGap app where you're loading your JavaScript from the file system. So there's some great tools out there that will do the work for you. You should have a look at JSMin, which is Crawford's JavaScript minification tool. UE compressor is also great from Yahoo, and the Closure compiler from Google. All of these are great options, and they should be integrated into your build process. Highly recommended. So On the subject of tools, Crawford also has a tool which is called a linter. And what the linter does is it essentially checks the quality of your code. If you're going to be adding minification to your build process, I would recommend also adding some linting, or there's another variation called JS hint, which is a little more configurable. And this will give you an indication of any problems in your code. It isn't specifically an optimization tool, but it will optimize your ability to write code and to find errors quickly. So another practice that we use a lot in mobile development is concatenation. So again, more relevant when loading scripts from the server, but also equally valid within a PhoneGap application. So if you look at the PhoneGap JS file, the source code for that is actually 16 different API files that contain, for example, accelerometer has its own JavaScript file. So when we build PhoneGap, we actually concatenate all of those into one file, which is PhoneGap JS, and that's what you include in your page. So there's less things to reference, and it loads quicker. So on the subject of writing code, an important thing to do, some basic gotchas are you should dereference long variables or frequently used variables within a loop. And I've got a short sample here. This is what you should not do. You can see that there's an object which is the app model.userinfo.contacts, which appears to be an array. And you can see that we're looping through every single contact, and we're looking for a contact with a certain ID. So we're find user by ID. And then we're essentially returning that contact. So the problem here is the fact that we're dereferencing this long variable every single time. So app.model.userinfo.contacts array has to be dereferenced. So a better way to do that is to actually store an alias to that contacts object. So now we've declared a local variable in our own scope pointing to that same array, and now we can loop over the contacts in that array and perform our search and return the particular contact. So what really happens when you have these long object chains is there's going to be a whole bunch of lookups to actually find the variable that you're looking for. So in this case, we're going to find the variable named app. We're going to look for a property named model. On that, we're going to look for a property named user info. And on that, we're going to find a property named contacts. So in the case of having, several hundred contacts in this list, this is probably something that you want to avoid, is all these extra lookups when you're actually just asking for the same data over and over again. So sort of on the same subject of finding users by ID, sometimes there's a better container that you can use. What is typically called key value pairs or maps you can use, assuming that your contacts in this list have a unique ID. You can actually just reference the item directly if you've stored them as an object map. So you would probably store them something like this, where you're receiving them from the server and you're grabbing the individual ID of that contact and you're using that where you're going to put the actual contact, and then you can dereference it later just by grabbing it by ID. So one small improvement that we can make to this is we can do the same thing with our contacts. We can dereference that long variable. And another thing is what's called lifting. So because we're looping through this array, in the last example, you can see that we've declared the variable contact, and that variable gets redeclared every time we enter that loop. So a better practice is actually, since we're going to be reusing that variable, we might as well declare the contact just outside, and then we can assign it every time we iterate through that loop. So another demonstration, I actually wasn't sure what the results were going to be, but I find them that they're quite impressive. I've always believed and heard that switch statements were faster than having a long if, else, else, if chain. So I'm going to do a quick demonstration that sort of shows the point in an extreme example. Okay, so much of this code is actually the same as the previous example. The only things that I've done here is now I've got 5,000 items in my array. I'm running my test 40 times, and I've declared a function which is test if else, and then another one which is test switch. So everything else within these loops is identical, so there should be no outside influence. And if we jump now to look at test switch, you can see I'm switching on the variable n, which is passed in, and then I've got a nice case statement that I didn't actually type this in, don't worry. I ran my script once to actually generate this case statement. So moving further down, we can see the test if else. So now we're doing a similar thing where we're going through and looking through 500 different values. So running this, you can see a huge difference between test 1 and test 2. So if we jump back to our code, we can see that test 1 was if else, and test 2 was the switch statement. And I mean, that to me is pretty drastic. So we spent 568 milliseconds in the if else, and we spent only 16 milliseconds in the switch. So I was surprised by these results. They definitely say that switch statements are quicker. I'm going to go over and run this test a few more times on my own because it was late last night when I wrote this, but it would seem to indicate that using switch statements is a very good thing. So I actually really like the way that my code looks when I use switch statements, and one little thing that I do when I'm validating forms is I switch on true. JavaScript allows you to switch on anything, so you can switch on a string and then compare different values. In this case, what I'm doing is I'm switching on true. I'm looking for the first true value in my list of things that I'm checking for. And the first true case here is actually going to mean that the form is invalid, so I'm going to return false. You could also use this same case ladder to actually set the error message or set the focus on the particular element that has the validation error as well. One thing to consider when using a switch statement is it's the best practice to test for the most likely cases first. So instead of testing for things that probably won't happen, if you know that something is likely to, put it first so you can save that extra time. So some key questions to ask yourself in terms of optimization. So is the performance really that bad? Looking at other apps, you know, some developers get completely anal about their code and they're worried that it's not running as fast as it could. But make a firm judgment on whether you actually do have a problem with your code. Perception is a huge thing. A lot of times people have performance issues and they think it's the result of bad code when really it's just not providing, you know, the hints to the user that something has happened or that something is about to happen. So, you know, responding to touch events and those sorts of things are really important to give the user the understanding that you are responding. So here's an example of a way that you could structure your code Am I still there? Just one brief moment. Okay. Back to it. One particular way that we could structure our code so that we remain responsive is instead of doing a bunch of work all at once, we can sort of slice off tasks for ourselves to do, keep track of where we are in the list of tasks, and that way we can still respond to user input. So in this example, we've got a process next value function, which is going to see if we've reached the end of the jobs that we have in our list. If we haven't reached the end, then we'll do one job, and then we'll set a timeout to call ourselves in a bit. So assuming that, you know, this do job is going to do some work with the actual job element, and you can also assume that touch start here could be responding to user input, and you could choose to stop processing, or you could have a cancel button and allow the user to cancel what you're doing. One thing that I hate when I'm using a web application is when I press a button too quickly because I didn't realize what I was doing, and then I have to wait for it to do whatever I just told it to do when actually I didn't mean to tell it to do that. So giving your user a way out if they have, you know, fast fingers like me is a very good thing to do. So moving on to the DOM and some critical areas that you should be aware of when working in the DOM and CSS. So here's something that I see quite frequently. What we're doing here is we're adding some items to a list, and the problem that we're having here is we're actually, every time through this loop, we're going to be modifying the DOM. So this is going to cause an immediate redraw of the document, and we're going to do that repeatedly for every single item in that list. So a better practice is to prepare your updates and do them all at once. So in this case, instead of actually modifying the DOM, what we're going to do is we're going to create a string, which is essentially the markup for what's inside the list, we're going to build up that string by going through our results. And then after we've built up that string all at once, we're going to insert it into the document. So this is a much better performing because we're not causing multiple redraws, and the app will remain responsive the entire time. So some DOM best practices are particularly related to lists and scrolling areas. You want to be very careful with your use of CSS gradients. If you can avoid using them altogether, that's the most insurance that you can get as far as performance. Browsers are getting better. WebKit has come a long way for CSS3 specific gradients and the way that they are accelerated on the hardware. Another thing to be aware of is when you have transparency, the items behind your transparent item have to be rendered before your actual item. So every time your item moves, even a tiny bit, you're going to have to redraw all of those items. So on most devices now, 3D transforms are actually accelerated in hardware, so you can get the best performance by manipulating items in 3D, even though you're not actually changing the Z value. I'm in Canada, so I say Z, but I mean Z if you're not from Canada. So another best practice when dealing with the DOM is the use of sprite sheets. Sprite sheets isn't anything new. It's been around, I think, since 2007 as a practice. But it's very similar to concatenating JavaScript. What you're essentially doing is you're combining all of your images into one large image, and then you're just manipulating which part of that image is shown. So you can use the same image for all your buttons at once, or you can use it for icons on a toolbar or other images within your application. So I'm going to be posting these links after. That one's kind of long. But I mean, Googling for CSS sprites, there's a lot of options out there and there's a lot of tutorials. This particular tutorial I like because it also covered a little bit of Photoshop and how to structure your images for best performance. So now that we have an understanding of how the code that we write runs and what sort of things we have to be aware of when we write that code, we can look at libraries in a different light and sort of see what library makes the most sense for us with our new understanding. There's a lot of libraries out there that will help you write structured JavaScript. They all have their varying ways of you doing things. Some particular interesting mobile UI frameworks are jQuery Mobile is the big one. Everyone's heard of jQuery, and jQuery Mobile is very close behind and an up-and-coming UI framework. Sencha Touch is a very, very good option with very rich interaction. There's a lot of code in there. You have to do things their way, and if you're coming from a jQuery world, you're probably not going to like it, but it does provide some incredible scrolling and other UI elements. Dojo Mobile is a viable option. I haven't spent a lot of time with it, but it is recommended. XUI is Nitobi's own UI framework, and it's sort of a jQuery work-alike, but it's made for mobile from the start, so it's very lightweight. It's a lot smaller than jQuery or any of the others. So another question to ask yourself is, do you actually need a UI framework? What I usually recommend is that you try to build your app first, because when you start getting into a lot of these libraries, you're adding more code than your application is without the library. And I never really like to see that. I like to write something that's actually tailored to the use cases that I'm covering within my application. So you can learn a lot from these frameworks, and you can decide on what works best for you. But there are some smaller options which just give you a part of the functionality and help you with some of the scaffolding and the MVC abstractions. So Backbone is a very good example of this. It's got a lot of helpers for things like events and data binding, but it doesn't really get in your way like some of the larger UI frameworks. Underscore is a great little library. It essentially, it is a utility belt. It makes a lot of functions easier to use, and it gives you a lot of special array ops and things. A lot of times, all you'll really need in terms of UI is scrolling, and this is the most common request and the holy grail of mobile development, especially in the iPhone world, is getting something that looks, quote, native. So numerous discussions on this subject. The one that I recommend is a little library called iScroll4. It has minimal impact on the way that you actually write your code. All you essentially do is you define a div that won't move, and with its content set to overflow hidden, and you put your content in it, and you initialize it as a iScroll, and the library does the rest. The best thing about iScroll is that there's no outside dependencies on other libraries, so it's really a great option. It's got nice scroll bars and very good momentum. So back to my slide, I should mention that I did write my own scrolling library. Unfortunately, I haven't had time to keep it up, which is why I'm recommending iScroll. He's made some awesome optimizations in terms of the momentum, and he's added things like multi-touch so you can pinch and zoom. My demo is actually going to cover Glovebox, which is the scrolling library that I wrote. But you can pretty much drop iScroll in place of my code, and things will still work. So I'll just give you a quick demonstration of the app. It's essentially a view framework with a little bit of scrolling. So it's sort of a starting point for an application. It doesn't actually do anything significant besides manage this little bit of scrolling that you have and switching between views. I noticed that on the screencast it doesn't look like it's very smooth, but I assure you it is actually quite nice the way it slides from screen to screen. You'll pick all this up in the movie. Or you can go to github.com/purplecabbage/ekiben, spelled like this, and you can run it yourself. So I'll just give you a quick explanation of how things are working here and how easy it is to actually roll your own view switching application with nice transitions. So in this code, I'm also using XUI, which is the UI framework, the little one that Notobi made. You can see glove boxes in here, and I've also got a simple event broadcaster, which you may want to have a look at. It's not actually used in this project, but I was preparing for future use, so this was like a typical app starting point for me. So what we're doing essentially, this is what a XUI DOM selector looks like. So we're going to grab the horizontal list of list items, and we're going to add a click handler. I've added a little sugar here with the function bind. So what this is essentially doing is it allows me to call on nav button as myself. So it's essentially just passing a closure back and applying the arguments to it. So when on nav button is called, it's going to be in my scope and not the scope of the event. So I'm creating some fake data to put in the list. This will be, of course, real data when you write it. And my nav button is what's going to actually do the switching between the elements. I'm going to jump down to the actual HTML and just show you the structure of the application. So we've got the navigation bar at the top. Inside that we've got what we're calling a horizontal list, which spans across the top. So inside that there's 3 list items, and they're view 1, view 2, and view 3 buttons defined in the span. And we've got what we're calling a view stack. So this is where we're actually going to be swapping views. The navigation is shown the entire time that you're using the application, but this is the piece that will swap back and forth. So we have 3 views. This is where we've plunked our fake data that we were creating. And these will be turned into glove box scrollable areas. So back to switching. So when we press a nav button, what we're going to do is we're going to first we're going to use XUI to add the active class to that navigation bar item. Then we're going to set some values. We're going to look at which item was actually selected, and we're going to set a current view based on that. Now we decide what direction we're moving based on what the previous view was and the current view is. And then we're going to call show and hide, which takes the direction, and it takes a current view and the last view. So show and hide here is going to call slide by ID with a view to hide. It's going to pass that direction, so this means that both items are moving to the left or to the right. And then it's going to call slide by ID with the item to show. At the end here you can see that slide by ID takes a value determining whether or not it's going to be showing that item or hiding that item. So the view that we're hiding, it's false. The view that we're showing, it's true. So in slide by ID, we're actually going to find the item with the ID that we were passed. We're going to do a sanity check to make sure we actually have an item. And we're going to pre-translate this item if we're showing it. So what this is doing is essentially moving it either to the right of the screen or the left of the screen. At this point, it's actually hidden. So after we've added this, we're going to remove the class hidden. Then later what we're going to do is we're going to translate it back to its normal location. So over 500 milliseconds, we're going to translate it back to 0, 0. So we have essentially pre-translated it. We've set up a a duration for that translation, so it happened immediately. Then we're going to set a delay on that translation, and we're going to let it slide back. If I open this, I'll show you how it all works in Google Chrome, which does a good job of so you can see what we're doing is we're moving the item off screen and sliding it in. And the one that's on screen, we're just sliding it off screen. So in this case, we look at the, that's if we're showing it. If we're not showing it, we're just going to look at the direction to know which way to slide it, and we're just going to make it happen. So we're also adding a listener for when that transition ends. And in this case, we're actually setting it to hidden. So this could be an opportunity for you to actually drop that item if you decided to make this more dynamic so that you were freeing up some space. The more elements that you have in the DOM, the more weight your application is going to have, and it can have an effect on the overall performance, especially with scrolling and animation stuff. So that's something to be aware of. If you wanted to extend this application so it had, say, 30 views, then you would definitely want to consider refactoring the code so that items are added dynamically and removed dynamically. So this is all open source. It's MIT licensed, so I'll let you dig through it to get a better understanding of how it all works. And I'm sure you'll love it. So it sort of demonstrates that you don't need to go the full way of, using a huge library to do the work for you. The amount of code that's in there is actually quite small, and if you look at it, you can probably learn a lot from it, and you can probably even improve it. And I welcome any contributions that you want to make back to the source. So some general considerations when you're building, especially a large-scale application, is you want to follow, model view controller conventions, and you want to separate your code into essentially silos so that things can be tested individually, and you're not, polluting the entire DOM when your application is running. Recommend that you try to think asynchronously and try to make everything as asynchronous as possible so you can always remain responsive to the user. I've been working on updating my event broadcaster class, which I'll be making open source as well. So it's just a simple implementation of add event listener, remove event listener. But I'll certainly be posting that on the PhoneGap mailing list when I've updated that. But I mean, these event systems are pretty easy, and if you use something like Backbone, you get that built in. So another important thing is if you're actually putting a lot of DOM elements into your HTML and you're not doing it dynamically, then you could consider putting your JavaScript code script tags at the bottom of the document. This is a best practice for improving load time. So the maker of iScroll, Cubic, he has posted some great stuff on his blog. He has a very good walkthrough of how jQuery works. And the thing is, a lot of times people think that jQuery is just the magic $sign function. And since now most browsers are implementing the document query selector all, it really is nothing more than that one line of code to get query selector functionality. So you can read up on his blog here. He goes into more depth about extending it and adding binding and ready events and those sorts of things. I highly recommend reading that. And it really shows you that you don't always need the entire library of code if you just want something, for example, like query selection. So there's a short example of the function bind. Backbone has this built in, as does the other one that I covered, underscore. So this is just a quick one-off if you just want a little function binding sugar in your code. It's really pretty simple. You can call that function as a method of that object, and you can do it on an interval and not have to worry about scope inside that function. So I'm going to move to a more thorough, quick demo of an app that I built. This was actually the inspiration for Ekiben, the Vue framework. And this is actually a full application that is also open source, and it's also in the Apple App Store. It's called SujiQ. So this is just essentially a more polished example of what you can do using a simple view like Ekiben. And it's not set up for looking nice in the iPad simulator, so I gotta restart. And it's taking forever. Xcode doesn't seem to like it when I switch simulators or first launch. Demo gremlin. Okay, 1 sec here. Yes, it happens to everyone. Okay, we may be skipping this demonstration. One more try. And I give up. Okay, I have one more quick example I'd like to show. The appropriately named test 3. So yeah. Thank you. I think that must have happened after. Okay, it's open source. You can go to Purple Cabbage on GitHub and you can try it yourself. Fix it and let me know what the issue was. So this short demo I've prepared is a demonstration of how you can cache data. I was looking for a compelling reason to demonstrate what's called memoization. Memoization is essentially storing values that are retrieved from a function. If they're frequently retrieved, then storing those values so that they don't have to be calculated again. The only compelling examples that I found of using this was calculating Fibonacci sequences, but there's better optimizations for actually calculating Fibonacci, and to me it doesn't seem like a very compelling use case. So I've adapted my demo a little bit, and now it's going to be essentially more about caching data received from the server. So I'll just run quickly and hopefully it'll just, one sec. Okay, so what we're doing is we're searching Wikipedia. Wikipedia has a great API that returns JSON, so it can make suggestions on things. So what I've essentially done is I've hooked up the onKeyChange event of this text field, and essentially every time it changes, I'm making a new call to the Wikipedia API. So it's actually remarkably fast. They've put some work into their server in terms of optimization. But most likely if the whoever manages the server in your company, or could be you, if you saw the number of requests that we're generating when we do this, you would probably freak out and go, I'm going to have to pay a fortune for that bandwidth. So let's have a look at this code here. So we've got a input search field with the placeholder text, search wikipedia.org. We're adding a listener. We're doing it in place to be quick and easy. So we're listening for the key down and we're calling on key up, which is awesome. Who wrote this? Okay, so actually it should be on key up because we want it to happen after. Okay, so what we're doing is every time we receive a key up event, we're setting a timeout. The reason that we're doing this is because when we receive the key event, the actual value inside that search text hasn't changed yet. So we're setting a 0 timeout, and we're calling on text change. So on text change, we're going to grab that value from the element, and we're going to call doWikiQuery. DoWikiQuery is a simple function that takes a string of text. We're going to create a URL. We're going to encode that text to make sure that it will be a valid URL. And this essentially is the heart of the suggestion API from Wikipedia. So we have a ready state handler. We're creating a XHR request. And we're calling send. when we receive a result, we enter our request handler here. We check the ready state, we check the response text, we grab the JSON result, we parse it, and then we call render results. The structure of the data is actually the first element is the text that you search for, and the second element is an array of strings, which are suggestions. So when we render our results, we're going to, first we create a string holder for the actual DOM elements that we're going to create. We're going to add up that string using the data provided, and then we're going to drop that into the results list. So in the inner HTML. So this means that every time that key is up, we're going to be calling the server. So an optimization that we can add is we can store the results in between. So when we go to do our query, if we have this result map, which is essentially a key value pair mapping, so mapping text values to arrays of results, we can actually skip the server call and we can just call render. So in order for this to work, we also have to, when we receive the data, we have to update our map. So essentially we're taking this result that we just got, we're storing it in the result map based on the search text, and we're storing what we actually render here. So now if we run this, and I'm not seeing the So you can see we're receiving on text change events. We're hitting the backspace. All of a sudden, we're not making the server call. You can see that we skipped the server call, and we're essentially just rendering the data that we got. So this is a huge optimization that will save us a lot of traffic and calls to the server. And that's optimization. So that's as far as I got with this actual example. The Wikipedia API is actually really good, and it will, if you continue on with this example, which I'll be posting, you can add the functionality to actually render results. So adding click-through support would be something that somebody could contribute. So we've sort of been through the entire scope of what mobile optimization is. The main thing is that you don't try to do too much with optimization. It's best to actually experience the issue before you try to fix it. So don't try to fix problems that you're not sure that you have, is my biggest piece of advice. And back to that original quote, don't write crappy code in the name of optimization. So at this time, I think it's a good time to take some questions. Steve is going to help me out. So if you just want to throw your questions in the chat. And I'll,
hey guys, you guys should have the ability to ask questions. There's a questions panel, so feel free to ask anything, and me and Jesse will be answering them. All right, guys, we're not seeing any questions coming up, so we might be wrapping up. Oh, wait, we got one.
the question is, if the initial DOM isn't very big, does putting the scripts at the bottom matter? In reality, the way the applications are being built these days, you're actually usually working with an empty body tag. So in this case, it's going to have very little impact. But if you are, laying out views, then it is best to actually put your scripts after. There's also some module loaders that have come a long way, which is another thing that you can do to optimize your code. There's a JavaScript project called Yes No, which allows you to do conditional loading of libraries. So this saves you from loading everything up front and allows you to essentially present your user interface as quickly as possible and then start loading the rest of the code that you need for the application. Modernizer has this built into it and also provides some ways of detecting features within the control or within the web browser. So that's a very good example of having to load different things based on what web browser you're using. So if you can do a staggered load, that's potentially better than actually just moving script tags around. Last call for questions. Your homework is to fix SujiQ. The question is, would I say that with these optimization efforts, a PhoneGap wrapped application could compete with a native app? Good question, and it's the question we get a lot. I don't like this distinction between what a native app is and what a web app and what a hybrid app is. To me, you should focus on building an app, and if that means that you want it to look like the iPhone, then you're going to have a lot of work in front of you to make that happen. Whereas if you try to make your app the best app and maybe focus on delivering a consistent brand across different devices, you'll have much greater success. A lot of the times when people talk about native look and feel, scrolling, it's really hardcore developers who are, not your typical user and probably not the people that you want running your app. These are people who are going to run it 2 or 3 times and either go, oh, it's awesome, or oh, it's not native. So I would recommend that you don't worry too much about going all the way to a native experience. You can certainly get close using these techniques, but that last mile is the toughest, and it'll vary based on the device. It'll vary based on all kinds of things. So the main thing is to remain responsive to the user and make sure that your app is usable at all times. Typical users aren't going to complain about whether that transition took 250 or 300 milliseconds. The next question is from Rob. He asks if it's true that mobile Safari has optimizations that make it more performant than UI WebView. This is absolutely true. They're using a different JavaScript execution model, which allows essentially the JavaScript code to be elevated to a higher permission and cached so that it can be run much quicker. This, unfortunately, will probably take a while before it makes its way into individual applications using UI WebView, but it certainly is a promise of the future. That said, though, the UI WebView has made some considerable leaps in speed on its own. So as time goes by, these things are just going to get better, and using a UI WebView and building what everyone seems to call a hybrid app is probably going to be the only way to build an app. Microsoft has already, at their build announcement, announced that you'll be building applications for Windows using JavaScript. So, I mean, that's complete validation of the things that we set out to do with PhoneGap, and we're excited that building PhoneGap for Windows itself will actually be very simple to do, given that they're already using JavaScript. Do we have any other questions? About cleavage? I don't see this one. Yeah. Okay, for those who don't know, I worked on a small project in my spare time, and it was based on PhoneGap, but one thing that PhoneGap doesn't allow you to do is to have multiple PhoneGap views within one application, or easily add a PhoneGap UI web view to an existing application. I called it cleavage because cleavage is another form of gap. In this case, it's a smaller gap, and I actually played with a lot of names, but I settled on cleavage because I'm a bit of a pervert too. But you can actually expect this to be integrated into PhoneGap sometime in the near future. It actually makes a lot of sense if you can separate some of your code and have views dedicated to particular functionality. it makes it a lot easier to work with your application and develop it and do things like divide work between developers. And that wasn't off topic, Rob. So Mikhail asks, PhoneGap is running mobile Safari, right? It's running a variant of mobile Safari, so it's essentially the same rendering engine, but there's a slightly different JavaScript execution model between the mobile Safari browser and the UI web view that's in PhoneGap. Essentially, everything looks the same within them. The only difference is some of the execution speed of the JavaScript, and also the fact that you have the address bar and the back button and all those, the Chrome around the actual browser. I'm getting the thanks. Thank you all for joining in, and we'll be posting the recording later so you can go back over it and see if you can get SujiQ to run, see if you can spot my error in the actual screencast and remix it on YouTube or something. Anyway, thanks a lot. Have a good day.
Okay.
Yeah, that's worth getting.
We're gonna put it on YouTube though. We're gonna feature it for sure.
Okay. There's no camera on me though.
No.
It's like that.
We never do that.
How am I supposed to be from the start? If no one can see my face. Maybe that's better because I won't be recognized. I can still go.